Okay, in this video I'm going to record confidence interval. So I'm going to cover confidence interval for the mean large sample and confidence interval for the mean small sample. Confidence interval for the mean large samples. So obviously, since we are going to figure out confidence interval for two different size of samples, large and small, that means there is some difference and there is different approach. And indeed, the sample size of 30 is considered cornerstone. Less than 30, it's a small size. Greater than 30 is a large size of sample. Now, why do we need to know the average? Because remember what we said when we were talking about bell-shaped, that's where data are centralized, and practically we are using the average to do analysis. Because that's where the main most of the data are centralized. You see here this hill, little bit hill, that's where we have the most of the data, and that's the average we are going to analyze. But before we analyze, because we are talking about the population, finding the population mean based on large sample, population mean based on small sample. So let's say we want to figure out the average age of population of United States. How are you gonna figure it out? If you start knocking door to door of every single household in United States, somebody will call 911 for you because it's not possible. Therefore, it's like I said in statistics, we are going to figure out it approximately. So within some interval. So that's how we're gonna figure out, and based on estimate in the sample. That's how we're gonna figure out the mean for the sample and then apply to the mean for the population. Why do we need that? Because based on that mean, we will do the analysis. Okay? We will do analysis of the given research result. Okay. So what we are going to cover, point of estimate, that's going to be point of estimate, it's going to be our average, our mean for the sample, and margin of error, with how much error we can afford. Construct and interpret confidence interval for the population mean, and figure out the minimum sample size that we have to calculate the average. Because let's say for 500,000 people, you can take a sample of 10 people, right? There is a way to calculate what is going to be minimum your sample size. So at the point of estimate is a single value estimate for population parameter. Most unbiased point of estimate for the mean is sample mean. Remember, that's exactly what I just said a while ago. To figure out the average for the population, we need to figure out the point of estimate will be the mean from the sample. So the mu, that's how we note mu, it's a population mean, while x bar is a sample statistic, which means sample mean. So point of estimate, let's assume we need to find the average of the friends on social networking website. So we, let's say, picked up random sample with 40 users, and we want to find the average. It's pretty easy. Those are all friends. Okay, so to find the in average how many friends has everybody in the on the website. So you add all these friends you have and then divide by 40 because it's for 40 people. Okay, so and that's how you're gonna find out that in average the users have 130.8 friends. All right. So point of estimate is gonna be 130.8. We just figure out. And we will learn a little bit later, we will learn the error, how much error we can afford. So average x bar plus minus the error, it's gonna be make our interval. In this case, error, we can figure it out easy. So 146.5 minus 130.8, 15 minus 87, 15 here is 5. So 4 minus 3 is 1. 15.7. Looks like the average is 15.7. If 138 minus 15.7, you should get 115.1. We will do this right after this, I believe. We'll see. Okay. What is it? Yeah. So, what is important in this case, we want to know with what level of confidence, level of confidence, we trying to estimate the population parameter. The lower is the confidence, the wider is going to be the interval, right? With the average in it. So, this is our confidence interval. It's negative z critical, positive z critical. This is our confidence interval. In okay, that's not what I want. So these areas, these tails, are we consider as an error, because if this one if this blue one is our confidence interval, dark blue, then light blue will be the error. And this positive negative z-score, we call z critical. It's going to be our critical value because it's going to separate error from confidence interval. So to find critical values, we are going to use standard normal table that we have same critical, same z-score table. Okay, so prepare your z-score table. You can put this recording on pause and prepare your z-score table. Let's see what we have. If our confidence interval is 90%, let's say if this is 90% confidence interval, that means that we are 90% confident that interval contains the mean is somewhere in this interval. Somewhere in this interval, because it's statistics doesn't give you any answer 100%, but it can give you the interval where mean will be located. Anywhere in this interval. It can be right at the border, it can be right in the middle, we don't know, but it is all we know that it's going to be within that interval. So if this confidence interval is 90%, okay, then what's going to happen? These tails are going to be our error. How this error is going to be calculated? We know that total is 100%, this database 100%, or portion wise is 1. So if this confidence interval is 90, then we're gonna take 1 and do minus 0.9, it's gonna be 0.1, right? So for error we have left 10%, 0.1 is 10%. Therefore, since we have two tails, errors on both sides, then we are taking 0.1 dividing by 2, we get 0.05. This is where from we get 0.05. Okay? Okay, 0.05. This is our probability, 5% here, area 5% here. How much will be our Z critical? This is what we're gonna do. So 5%, we're going to look at negative Z-score, correct? So we are going to look at negative area, negative Z-score area, find where our 0.05 is, and find the Z-score. Okay, and that Z-score, I bet it's going to be negative 1.645. Negative 1.645. So since we have negative 1.645, I bet it's gonna be in the middle of let's say 0.04, and in the middle 0.05. Therefore we get 45. Okay, look at the table, you should be able to find it. Sampling error. So just like anything we calculate in statistics, we always are leaving space for error, just because our statistics never gives us anything 100%. So sometimes error is more important than our confidence interval, because let's say for the pills, it's error, it's going to be side effect, right? So that's how do you think they find all these 20 lines of side effects? That's a sampling, that's an error, sampling error, based on which they are figure out the side effects. Okay. So what is sampling error? The difference between point of estimate, which means average of the sample, and actual population parameter value. For mu, to identify how much is our error when we identify average of the population, it's going to be x bar minus mu. X bar minus mu. X bar is it's a average of the sample, and we subtract the true value of the average. That's going to be sampling error. But we are identifying this theoretically because we don't know how much mu is. We are heading towards identifying this mu. Okay, this is theoretically, we said, let's say if true average of population is 15.8, let's say, and we found out a sample for the sample the average for the sample 10.8, so the difference is going to be 5. 10.8 minus 15.8. So mu is generally unknown. That's exactly what I'm trying to tell you. It's unknown. Our goal in this the section to identify the average for the population. Okay. And x obviously varies from sample to sample because it's based on a sample size, right? Okay. So margin of error. So instead of error, we are going to see how much will be the maximum of error, because margin of error, nothing else but margin of error. This is the formula. We don't need this. This is the formula for margin of error is equal z critical times standard deviation. When n is greater or equal 30, the sample standard deviation can be replaced with sigma, okay, and divided by square root of n. The square root of n is a sample size, so you divide by sample size. One more time, zc, that's a z critical. We will find it based on given probability of error. And this is standard deviation for the population, and n is a sample size. Okay. Sometimes called maximum error. I already mentioned. Yes, error we call maximum margin of error. So here is example to find margin of error. So let's write down from the beginning the formula. Margin of error is equal z critical sigma over square root of n. Okay, moving back. Use the social networking website data and 95% confidence level to find the margin of error for the mean number of friends for all users of the website. Assume the sample standard deviation is 53. Okay, sample standard deviation is 53. Why we don't put because it's sample standard deviation, we could put S and S. Because standard deviation for sample, we use S. Standard deviation for the population, we use sigma. But we put here, we can replace it with sigma because our standard deviation for the website, it's n, where n is equal 40, more than 30. Now you will ask where from. This n is equal 40, it's taken from the previous example we were solving social media, that where n was equal 40, okay? So I will write down n is equal 40. And what else? Confidence interval. Or confidence level, I'm sorry. Confidence level is 95%. Okay, let's see, which is 0.95. So let's see what we have. Do we have sigma? Yes, we have. Do we have sample size? Yes, we have 40. All we need to find out z critical. How can we find out z critical? Through confidence interval. Yes? Okay, let's find out. Confidence interval 95% or 0.95. So 100 minus 95 is 5%. And for two-tail, 5% by 2, 2.5%. That will be 0.025 and 0.025 here. Oh, previously I forgot to tell you something. I'll tell you here. It's not a big deal. So by two position, 1 and 2. So we get 0.025. Going into table. Obviously, we are going into negative z-score table because 0.025 is 2.5%. It's going to be negative 0 at the table. Let's say we found 0 at the 0.025. So how much it is in negative 1.9, and here should be 6. Now, how to find positive version? I'm going to show you shortcut because the book is going a little bit longer way, because usually these errors are symmetric. They are no, it's asymmetric and they are equal. Therefore, whatever value you get for a negative z-score, you flip the sign and get the positive one. You will never see different values by absolute, meaning you won't see different values. If here negative 1.6, here is positive 1.6, negative 196, you flip the sign, positive 1.96. That's how will be easy for you to figure out. Okay, so here it all explains, same thing I already told you. So solution finding of margin of error, here it is. We found 1.96. We always use the critical positive because error cannot be negative, right? Error we use by absolute value is positive. This is why we are going to take the critical always the positive. Okay. So plug the standard deviation, square root 40, you get 16.4. So what do you do first? You can multiply 53 by 196 and then divide by square root 40. Or you can divide 53 by square root 40 first and then multiply by 196. Not a big deal. So what does that mean here? That with 95% confidence we can insist that margin of error for the population mean is about 16.4. Is about 16.4, the margin of error, and we will get the interval here. So now let's find the confidence interval. That is going to be this formula. Mu is greater than x bar minus error and x bar plus error, where formula for error we're already familiar with. So let's find the confidence interval for our case. So those are instructions in words. I don't need to read it. You can read yourself. I rather show you how to work with it. Otherwise, reading it's not gonna give you anything. You can read this by yourself also. So, constructing confidence interval. Construct 95% confidence interval for the mean number of friends for all users of website. What did we have here? From the previous problem, again, we have 130.8, that's the average, and margin of error, we calculated 16.4, correct? Therefore, the left and the right point, it's going to be mu, that is going to be greater than x bar minus error, and less than x bar plus error. And accordingly, we plug the numbers. Average 130.8 friends. Again, this x bar and margin of error we took from previous calculation. So 130.8 minus 16.4 and 130.8 plus 16.4. And this is, it's going to be the interval where our mu is located. Okay. Once we place it here, 130.8, 114.4, and 147 and 2. By the way, didn't we calculate 16.4, or this is different case? Yeah, I think it's a different case. So margin of error 16.4. Yeah, 16.4. Okay, so confidence, with 90% confidence, we can say that population mean located within 114.4 and 147 friends. And this is the solution. Next one. This is very, very important, guys. A while ago we solved the problem when sigma was known. Now again we are going to solve the problem when standard deviation is known. A college admission director wishes to estimate the mean age of all students currently enrolled. Okay, in a random sample of 20 students, n is equal 20 students, that's not what I want. Blue color, n is equal 20 students with mean age found to be 22.9. So mean age, because it's a sample, so our average mean age is going to be x bar, right? 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population normally distributed. Construct 90% confidence level. So confidence level is 90%. Okay, of the population mean age. Well, let's see how we're gonna solve it. If it's 90%, 0.9, that's mean 10% is falling on errors. This way, which means 5% per tail of error, right? So what we're gonna do next, of course, we are taking 0.05 and go to the table. And again, remember, let me remind you, because it's a 0.05, it's a 5%, and percent is located in the body of the table. So you find here 0.05, and go horizontally, vertically, find your z-score, which is going to be negative 1.645, and we are looking on this page of negative of z-score because 5% is less than 50, like I said. And once you found negative z-score, you are flipping the sound and the sign and find the positive z-score. Next. Once we have positive z-score, we need to find error, right? Because we are heading to find the the area where mean of population located. Okay. So E is equal Z critical sigma over square root of n. So Z critical we found 1.645. Sigma was 1.5 and square root of n is square root of 20. And the answer is 0.6. Okay. And accordingly, the confidence interval is going to be, because 22 and 9, that was our average, remember, from the table, from the word problem. So minus 0.6 and x bar plus 0.6, and we find this area, this interval. Okay, now let's draw this interval, and this is where it's going to be point of estimate 22.9, and the interval is going to be 22.3 and 23.5. So what is the conclusion? That with 90% confidence, here we go, we can say that average age of student is between 22.3 and 23.5 years. Okay? It's not difficult, is it? So moving to, those are practically, this is what it's talking about. I'll just tell to people who are interested. to how to get closer to the true value of mean. So you take the more samples you take, let's say you do several times several samples, and then take all samples of the samples, right? And that's how you can figure it out, the nearest, the closest to the true value. Okay? Sample size. Remember at the beginning I told you that there has to be minimum sample size that you have to take to be able to provide these calculations and analysis. So the minimum sample size you can take is Z critical sigma over E squared. And this formula, again, coming out, not again, but it's deriving from the formula. Error is equal Z critical sigma over square root of n, right? For the people who are interested, how we get this n, I'm going to write down error is equal Z critical sigma, because it's multiplication, I can move on the top, square root of n. I need to find n. How? So first thing I have to do, get rid of square root. How we get rid of square root? When we square it, right? Which means we square here also. And we are going to get E squared is equal Z squared sigma squared. Or I can even put the sigma squared, doesn't matter, over n, right? Because square root n, when you when square root n you square it, you are getting clean n. Okay? So, and n from here, it's gonna be equal. Now if I take this, because it's equation, it's common denominator. If I divide by n and multiply by n, and if denominator is common, I can drop it. So as a result, I will get n E squared is equal Z sigma, Z critical, sigma together squared I put. And n from here will be equal, if I divide by E squared, because I need n by itself, divide by E squared, this is gone. And this is the formula I'm getting, n is equal Z critical sigma squared over E squared. Well, makes sense. They put everything in square, in parentheses. Yeah. Okay, so this is the formula for minimum sample size. Let's solve problem. You want to estimate the mean number of friends for all users of the website. How many users must be included in the sample size? So meaning what sample size you have to include to use with 95% confidence level that the sample mean is within 7 friends of population mean. When it says within 7 friends, that means plus minus 7 friends, which means that's a deviation, and that is the error. So our error is 7. What else we have? Confidence level is 95% or 0.95. Sample standard deviation S is equal 53. And what else? Estimate the mean number of, again, n is going to be 40, I would say, because we are talking about same friend from the social network. So, to find, first of all, it's 95%, which means error is going to be 0.025. and it's going to be plus at the negative 196 and positive 196, the critical. Next, sample minimum sample size is going to be z critical sigma over margin of error. You plug the values, you square it, and you get 220.23. Now here we round up till 221. Even though if you would round algebraically, it will be 220. But because we are dealing with life existence, meaning people, or it can be bird, or it can be animal, you are not going to take half of the person, right, in the sample. Besides, this sample size is the minimum, so therefore it doesn't matter if we take one more person in there. All right, at least 221. Well said. At least 221 users can be included in the sample. Okay, I'm done with 6.1. Next will come 6.2.